The first and probably least effective way is to graph it. Why I say it's the least effective, it's really hard to graph something perfectly unless you're a calculator. And if you make even the slightest mistake while graphing it, it's going to look wrong. All right? So if I had two lines like this, and I said, what is the solution to this system? The solution to a system is where those two lines actually intersect. So our solution is going to be right smack dab right here. That is the solution. So a solution to two equations is that overlap. It is that overlap. So in this case, it's going to be the point -3, 1. So it's going to be -3, 1. Or you could put it as x equals -3 and y equals 1. Our next one, we're going to actually solve by graphing. Now, when I solve by graph, there's a bunch of different ways to do it, but I'm only going to go through one way, and that is put in slope-intercept form. The other way you can do it is you can replace your y's with 0, find your y-intercept, and then replace your x with 0, and then find that intercept. But we're going to put this into slope-intercept form just because we can practice slope-intercept then. So if I have 2x minus y equals -8, slope-intercept form is going to be that form y equals mx plus b as a quick review. Does anyone remember what that m stood for? Yeah, it's the slope. Yeah, so your m is your slope, which means your b is your intercept. It's slope-intercept form. So I want to turn both of these into y equals mx plus b. So we're just solving for y on both of them. So the first step might be to subtract 2x from both sides. So that'll give me -y equals a -2x minus 8. Now I do need to get rid of that negative, which means I'm going to multiply everything by -1, which is going to result in y equals 2x plus 8. All right, let's graph that first. Let's graph that first, and then we'll do the other one. All right, so we have y equals 2x plus 8. Now remember that 2 right there is your slope. That is your slope. And sometimes it's easier to think about it as being 2 over 1, where 2 is your rise, and 1 is that run. It's that rise over run. Up to left to right. So the first thing I'm going to do is I'm going to plot that 8 on the y-axis. So we're going to find 8 on our y-axis. It's a positive 8, so we're going to put a point right there at the top. Well, here's a slight problem. It says it's supposed to go 2 over 1. Well, 2 over 1 would be going up 2 over 1, but that isn't on my graph. So rather than going up to right 1, I am going to go down to left 1. So I'm going to go down to left 1 just like that. It is still, if you look at it, it's still 2, 1. It's still rise over run, but we just gotta go backwards because that's how our graph works. So down 2 over 1, down 2 over 1, down 2 over 1, and realistically you only need like 2 to make a perfectly straight line. All right, so I'm gonna go ahead and graph that. And that's one of my lines. Graph the other one, I'm going to do the exact same thing. I'm going to put it into slope-intercept form. So we are going to have 2y equals -x plus 6. Divide everything by 2. And we are going to have y equals a -1 over 2 times x plus 3. That plus 3 tells you where it's going to intersect the y-axis. So it intersects at 3. So it would be that point 0, 3. Right here. Maybe I'll change the color. Maybe I'll use green. And now we're doing -1 over 2. So that means I'm going to go down 1, right 2. So down 1, right 2. Maybe down 1, right 2. Maybe I'll go the other direction. That'd be right there. And so that line is right there. So the solution to this will be where the two lines intersect. They intersect right here. And that's going to be that point -2, 4. Or you could say x equals -2 and y equals 4. Personally, I think this is the dumbest way to solve a system of equation. There's lots of mistakes that can happen in there. Your graph might not look perfect. And anytime it's a decimal answer, like if it's 2.4, it's really hard to see 2.4 on a graph, unless you're really good at it. So I am not going to ask you to graph and solve using graphing. All right? But what I might do is on a test, I could put this drawing on there and say, what's the solution to it? Or I could do a more complex drawing and say, what's the solution to it? Solution 2 is always where it intersects. Where does it overlap? That is always the solution. So you should know what it looks like. You should know how to graph lines. All right? You should know how to graph lines. So if you don't know, practice that. All right, but let's get into better ways to solve equations. And the first one we're going to talk about is elimination. With elimination, you're just trying to create a zero pair. That means if you have a positive 2x, you want to have a negative 2x because you want something to turn to 0. You want something, when you add the two equations together, they just cancel out. So you need a 0 pair. Once again, if I had negative 3x, I'm looking for a positive 3x on the other side. But it doesn't always have to be an x. If we look at these two equations, I have 3x minus y equals 9. In the other equation, I either need a negative 3x, I don't have that, but I do have a positive and negative y. So I really don't have to do any work at all. What I'm going to do is I'm just going to add these two equations together. And I'm going to do element by element. So I'm going to do 3x plus 2x equals 5x. Negative y plus y equals 0. So that's what we mean by elimination. I get rid of my y's. And that's going to equal 10. Well, we don't care about 0, so we're just going to have 5x equals 10, or just x equals 2. Now we need to solve for y. You have to have an x value, you need to have a y value. So all you're going to do is you're going to take this 2, and you're going to plug it in for either one of these equations, whatever one you want to. I usually pick the easier one. Like if one was like 1/2 x and one was 2x, I'd probably pick the 2x, the one that's easy to multiply. So what I'm probably going to do is I'm going to throw this 2 in for that x there, because it's only 2 times 2 then. So all we're doing is we're taking this 2 and we're actually plugging it right back in for that x. And that is going to give me 2 times that new 2 in place of that x plus y equals 1. Well, that's 4 plus y equals 1. And we're just going to end up with y equals a negative 3. What's probably a really good idea right now to make sure you didn't make any stupid mistakes? Liv. Check it. How do I check it?
You plug in negative 3 for y, 2 for x into one of the equations.
I'm going to write it down here in my check. But most often, because you have a calculator, what I would do is I would just plug in my calculator real quick. Like I would just do 3 times 2 minus negative 3 and make sure it equals 9. Really quick on your calculator, just check to make sure you are correct. But I'm going to actually write it out this time because it is our notes. So our check would look something like this. We're going to replace all the x's with 2. So we'd have 3x, but instead of that x, we're going to put 2. minus my y value. My y value was a negative 3. It should equal 9. Well, if I do the math, it'd be 6 plus equals 9. So we have 9 equals 9. That works out. And then I'll do the same thing for the other one. I'd have 2 times my new x value is 2 plus that negative 3. According to that, it should equal 1. Well, 2 times 2 is 4. Minus 3 does equal 1. We have 1 equals 1. We are good. I didn't make any mistakes. Tell you guys, just check it on your calculator. It doesn't take long. Most of the time, you can do it in your head, too. Most of the time, you can do a quick check in your head. All right, the harder one. There is no zero pair. If I would, don't copy this down, but if I was to add these two together, I would have 5x minus 5y equals 10. That doesn't get us anywhere. I didn't eliminate a variable. So we need to get a zero pair. And in order to do that, we're going to multiply the top equation, the bottom equation, or both equations by a number that will result in a zero pair. So some tips. Look for one you can easily multiply. So say I have negative 2 and a positive 4. Just multiply the negative 2 by 2. All right, in this case, we don't have anything nice. We have a positive, a negative, so none of them are even close to being zero pairs. Can someone give me an idea what I should multiply both of those equations by to create a zero pair? I don't care if you're doing it with the x or the y. Oh.
Multiply the top equation by 3 and then bottom equation
By negative 2, perfect. So it looks like you're trying to get rid of the x's, right? Because a 3 times 2 would give me a positive 6. A negative 2 times 3 would give me a negative 6. It is okay if you eliminated the y as well. To eliminate the y, you just multiply by maybe a positive 2 and a negative 3. All right, what that's going to result in. Now, here's the biggest mistake people make. Make sure you distribute this 3 to everything, including the other side of the equal to sign. All right, so we're going to have 3 times 2, which would give me 6x. 3 times a negative 3 would be a negative 9y. Equals a 3 times that negative 2 would be a negative 6. Multiply both sides, or this entire equation, by negative 2. Negative 2 times that 3x would be a negative 6x. Negative 2 times a negative 2 is a positive 4y. And finally, a negative 2 times 12 is going to be a negative 24. If when you check your answer, you are wrong, 90% of the time is just because you didn't distribute your number to the other side of the equal to sign. All right, now when I add these two equations together, I'm going to have 6x minus 6x, which is just going to equal 0. Then we'll have a negative 5y equals a negative 30, not 36, but 30. And so we're going to have negative 5y equals a negative 30, so y is just going to equal 6. Now you have lots of places to plug that 6 into. You could plug it in for that y, for that y, for that y, or for that y. Any y you want to replace it to will work. I'm just going to pick the smaller one. So that's that negative 2y plus 12. So I'm going to plug that y in there. So we are going to have 3x minus 2 times, my new y is 6, equals 12. That'll give me 3x minus 12 equals 12. We'll have 3x equals 24. So we're going to have x equals 8. And if you check that, those will be correct, which I would get in the habit of checking, at least with my calculator, all right? I'm not going to grade you on you guys checked it, all right? What that check might do is might get you a little point, like maybe you made a mistake and you showed you checked it, but somehow you checked it wrong, which is hard to do, but it happens, then you can get an extra point because I saw at least you checked it. All right, so that's elimination. That is my favorite. That is my favorite of all three things. My slightly less favorite is substitution. The problem with substitution is you're moving a whole bunch of stuff around all at once. Where elimination is you just multiply one equation by a number, the other one by another number, you add them together, and generally you are done. So what substitution is, You are trying to, in one of these equations, you're trying to solve for a variable, which means in one of those equations, you want like y equals a whole bunch of stuff on the other side. Or you want x equals a whole bunch of stuff on the side. And the quickest way to do this is find the one that looks like the most lonely variable. What I mean by that is this has a 6 in front of it, a 5, a 3. This just has a 1 in front of it. It's just a -1, so it's probably the easiest to solve for. So I'm going to solve for this y. I'm going to solve for that y. It would work for anything, but I'm going to solve for that one. I know I'm not going to have any weird fractions then. So I'm going to solve for y. So in the process of doing that, I would move the 3x to their side, which will give me -y equals -3x plus 6. Multiply both sides by a -1, and we're coming with y equals 3x minus 6. So I'm not a huge fan of substitution. We got to move all that into the other equation without making any mistakes. So we need to take the fact that y equals 3x minus 6, and we need to plug it in here. Common mistake that people make is they plug this back into the one they were working on. So they plug it into that x, this y, and they end up with something like 0 equals 0. You always have to plug this into the other equations. So you use one equation to solve for a variable, and you plug it into the other equation. Otherwise, you end up with like 0 equals 0 or something that's true, like a 6 equals 6. So we're going to go ahead and plug that in, which will give me 6x plus 5 times, in parentheses, that 3x minus 6 equals a -23. Now we need to solve it. So 6x plus 15x minus 30 equals a -23. 6x plus 15x, that's going to be 21x. And that's going to equal, well, we add 30 to both sides, so that's just going to equal a positive 7. And we're going to end up with x equals 7 over 21, which actually equals 1 over the squiggly line, which should have been 3. So for y, I have to plug that 1/3 into either that x or this x. I always look for the easiest one. What's 3 times 1/3? Just 1. 6 times 1/3 is just 2, so either one of them would be pretty easy to work with. I'm just going to pull down that 3x minus y equals 6, since they're both kind of the same. So we're going to use that 3x. Maybe I'll put a little wall up, saying this is something else. So I'm going to pull out that 3x, not that 3x. Yeah, 3x. 3x minus y equals 6. We're going to take that 1/3 and plug it in here. And so I'm going to have 3 times 1/3 minus y equals 6. 3 times 1/3 is just 1. Minus y equals 6. Subtract 1 from both sides. Negative y equals a 5. And y just equals a -5. I didn't put anything else on there, did I? Any questions on graphing, elimination, or substitution? And realistically, what we're doing is we're taking like a whole section of algebra and plugging it into one day. All right, so if you have questions, please ask. The last thing we're going to talk about is this, and then we'll get to a word problem. You have to know these terms. You have to know these terms because I'm going to tell you to solve it, and you have to describe what it is. All right, the first thing we're going to talk about are consistent solutions. You have 2 types of consistent solutions. So a consistent solution has at least one solution. It could have 2, it could have 4, it could have an infinite number of solutions. But a consistent has at least one solution. It is an independent, consistent system if there is exactly one equation. So independent is where you have exactly one solution. On a graph, that would be intersecting lines like we had for the very first two examples. So intersecting lines means it has one solution and it'd be independent. In other words, you just have the answer x equals 3, y equals 4. A dependent, when we're doing a system of equation, is going to be an infinitely many solutions. In form of a graph, it'd be two lines on top of each other. All right, they'd be the exact same line. If solving an equation is a true statement. In other words, if you were actually solving a system of equations and all the variables drop out and you end up with 3 equals 3 and you're like, hey, that's a true statement, it is infinitely many solutions. So once again, if you're using substitution or elimination and both of your variables drop out and you end up with like 3 equals 3, 6 equals 6, and it's a true statement, you have infinitely many solutions and it becomes dependent. The last thing we're talking about is inconsistent. That just means there's no solutions. Graphs of those would be two parallel lines that don't touch. You're going to know it if you're using substitution or elimination and the variables drop out and you end up with a false statement, such as 5 equals 9. Questions on that? So your big ones are independent, dependent, inconsistent. Sometimes I'll ask if it's consistent or inconsistent as well. But you have to know those terms. All right, the very last thing we're going to do is we're just going to go through a quick word problem, because everyone loves them. So we have some people on a stakeout protecting Earth, obviously. We have Agent Mulder observed 5 men in black enter a coffee shop and get 3 donuts and 5 coffees for $3.30. Next, 3 aliens in disguise entered the shop and got 4 donuts, 3 coffees for $2.75. How much does a coffee and a donut cost? So this guy's terrible at stakeouts because somehow he got the price at the end, but he missed giant signs that say how much stuff is worth. So we're going to just go with it. So we're going to go with the first statement. It says that you have 3 donuts plus 5 coffees equals $3.30. So let's have donuts. Let's start with donuts. Let's let donuts be a capital D. And we'll let coffee be a capital C. Why not, right? All right, so it says if you have 3 donuts plus 5 coffees, it's going to equal $3.30. So that means we have 4 donuts, or 3 donuts, so 3 times D, plus 5 coffees, which would be 5 times C, is going to equal $3.30. So I just took this first sentence and turned it into a math equation. The next one is 3 aliens in disguise entered the shop and got 4 donuts and 3 coffees. So we have 4 donuts, so that'd be 4 times D, plus how many coffees do they got? They got 3 coffees, so that'd be 3 times C, and that's going to equal $2.75. Do I really care how many aliens there are? No, I just need to know the cost. All right, so we have 3D plus 5C equals 330. 4D plus 3C equals 275. I'm going to go ahead and let you guys solve it. You can use substitution. You can use elimination. I don't suggest you graph it because they come out to decimal answers. In fact, I'll put the answers on the bottom corner. You should come up with C equals 45 cents. And the donut is going to equal 35 cents. I can't tell you there's a 99.9% chance there will be a word problem on the test. That'll be similar to this.